All rubber-tired, self-propelled electric haulage equipment used in active workings of underground coal mines, with the exception of personnel carriers, must be equipped with automatic emergency parking brakes in accordance with the requirements of Section 75, 523-3 of the Code of Federal Regulations. This video will explain these requirements, and using this special display panel or brake stand will demonstrate how the automatic emergency parking brake system works and how it complies with federal regulations. The display panel shows a system suitable for haulage equipment. Non-haulage equipment is covered separately under Section 75, 523-3D and will be addressed later in the video. The primary component of the automatic emergency parking brake system is the spring-applied brake caliper. The spring pack in this section supplies the brake pad clamping force. This cutaway of a similar brake caliper shows the internal components. The Belleville springs supply the clamping force when the brakes are applied. To release the brake, hydraulic pressure must be supplied to push the piston back and compress the springs, thereby freeing the pad from the disc. In this demonstration, hydraulic pressure is supplied to the brake through a hydraulic hose. Notice the hose movement when the brake is applied. This type of hose movement may be observed on brake systems installed on machines in the field and provides an excellent indication of whether or not the spring-applied brake caliper is receiving release pressure. When the panic bar is hit, hydraulic pressure is quickly dumped from the caliper and the spring-activated brake is applied. This will quickly stop the machine in an emergency. This system complies with paragraph 75, 523-3B1, which states, automatic emergency parking brakes shall be activated immediately by the emergency de-energization device. To initiate this braking action, the hydraulic fluid in the caliper must flow back to the hydraulic tank. The faster the fluid is dumped to the tank, the faster the brake will be applied, an important factor in emergency stopping. This brake system has a pilot-operated dump valve mounted between the caliper and the hydraulic tank. This dump valve provides a short and non-restrictive flow from the brake caliper to tank. This allows for a fast system response time. Paragraph 75, 523-3B2 requires that the automatic emergency parking brake engage automatically within 5 seconds when the equipment is de-energized. This can be demonstrated by simulating an intentional equipment de-energization. When the machine is shut down, hydraulic pressure is automatically dumped from the brake caliper, resulting in automatic brake application. For this system, it took several seconds for the pump to wind down and system pressure to be depleted enough to permit the spring-applied brake to act. This is acceptable because the machine would not be in an emergency situation during a routine shutdown. In the case of an unintentional loss of power, such as a cut trailing cable, the 5-second interval would give the operator time to brace himself before the automatic emergency parking brakes were applied. It should be noted that the 5-second allowance does not apply when the machine is de-energized by the panic bar. Actuation of the panic bar must immediately apply the automatic emergency parking brake. If there is a long time lag between panic bar actuation and when the brake starts to apply, the system would not be effective in an emergency and would not meet the Part 75 requirements. Paragraph 75, 523-3B3 requires that the automatic emergency parking brake shall safely bring the equipment when fully loaded to a complete stop on the maximum grade on which it is operated. The standard does not require a particular level of stopping capacity. Instead, automatic emergency parking brakes must be suitable for the equipment on which they are installed and the conditions under which the equipment is operated. This cutaway shows a typical internal spring pack found in parking brake calipers. The spring pack consists of a series of individual Belleville springs. Each spring looks like a concave washer. When flattened together, the spring pack provides a great deal of force. As the spring pack extends, the force rapidly decreases. Therefore, as the pads wear, the springs must extend farther in order to provide the pad clamping force, thereby reducing braking capability. The brake shown here has an adequate pad wear life of 1/8 inch per pad. A 1/8 inch wear allowance per pad permits enough duty life to reduce the need for frequent brake adjustments relative to mining equipment maintenance schedules. Part 75 does not require a specific wear life, but instead contains the performance requirement that the brake must hold the machine on the steepest grade where it is used. It is up to the operator to ensure the brake pads are adjusted or changed when necessary. The automatic emergency parking brake system demonstrated here includes a pressure switch that prevents tramming with dragging brakes. It is not required by federal law, but it is a possible option. A hydraulic line from the pressure switch is tied into the brake release pressure supply. If the brake release pressure drops below a preset value, the electrical contactors in the enclosure open, preventing power from getting to the tram motors. This makes it impossible to tram the machine with dragging brakes. Paragraph 75 523-3B4 states that the automatic emergency parking brake shall hold the equipment stationary despite any contraction of brake parts, exhaustion of any non-mechanical source of energy, or leakage. The spring-applied brake caliper on the test board meets this requirement. The springs will keep the brake applied regardless of any hydraulic leaks or contraction of hydraulic fluid as it cools. Here is an example of a braking system that does not meet this requirement. The service brake pedal must be pushed to pressurize the line from the master cylinder to the service brake caliper. The locking valve is installed in this line and acts like a check valve by trapping a column of pressurized brake fluid between the locking valve and the brake. This type of brake will release if several drops of brake fluid leak back through the locking valve, or if the brake fluid cools and thermally contracts. Since brake fluid is non-compressible, it takes only a small amount of leakage to cause the loss of braking force. If the machine is parked on a grade, this type of brake may hold it stationary for a short time. But after the brake fluid cools and contracts, or after leakage of several drops of fluid, the braking force disappears and the machine could coast or start moving down grade. Paragraph 75 523-3B5 requires that the automatic emergency parking brake shall release only by a manual control that does not operate any other equipment function. The park valve on the test board controls only the automatic emergency parking brake. Therefore, it is acceptable. Some existing brake systems do not meet this requirement. For example, scoops that are provided with a single control that both releases the park brake and operates the pusher blade would not be acceptable. Similarly, a single control on a shuttle car that releases the park brake and operates the conveyor boom would not meet 75 523-3. Manufacturers have utilized these systems in the past. However, they do not meet the new automatic emergency parking brake requirements. A brake release control which operates the automatic emergency parking brake coincidentally with another function can lead to an unintentional release of the brake. For example, If a single control releases the automatic emergency parking brake and operates the conveyor boom on a shuttle car, the equipment operator could inadvertently release the brake while attempting to raise or lower the conveyor boom. Such human error can allow equipment to unexpectedly roll and cause an injury. All automatic emergency parking brake systems with a brake release control that coincidentally operates another machine function will have to be modified to meet 75-523-3. Paragraph 75-523-3C1 requires a means in the operator's compartment of haulage equipment to apply the automatic emergency parking brake manually without de-energizing the equipment. The park valve provides this capability. For example, when positioned on an unloading ramp, a shuttle car operator could set the brake before changing seats by operating the park valve. Paragraph 75-523-C2 requires a means in the operator's compartment of haulage equipment to release and re-engage the automatic emergency parking brake without energizing the equipment. The manual hand pump meets this federal requirement by providing a means to release and re-engage the automatic emergency parking brake without energizing the machine. If a vehicle becomes disabled, the pump can be manually operated to release the brake in order for the machine to be towed. Here, the hand pump is being used to release the automatic emergency parking brake. The brake is now released, and the vehicle could be towed. To reapply the automatic emergency parking brake, a thumb screw on the pump can be used. Some spring-applied brake systems not provided with a manual pump require backing off the spring with a wrench at the caliper. This would not meet Part 75 for haulage equipment. A hand pump valve on the test board is used in conjunction with the hand pump. It directs flow from either the main pump or the hand pump to release the automatic emergency parking brake as necessary. The hand pump is only required on haulage.